Physics of stringed instruments. Number 1, electric basses, elements that affect the tone and dead spots of a solid body electric bass. This video explores the factors that affect the sound and dead spots of a solid body electric bass. The conclusion is that the material and shape of the neck, nut and body all affect the sound. First, let's talk about the wood used for bass guitars. Wood is a polymer like polyethylene terephthalate, which is the material of PET bottles. However, unlike PET, cellulose does not melt when heated. The main component of wood is a polymer called cellulose, and the cellulose fiber itself is soft and easily deformable. This time, we will use data from a paper published in 1999 called Dead Spots of Electric Basses by Dr. Helmut Fleischer, a famous German musical instrument researcher. These are the two types of bass guitars he used in his research. The bass guitar on the left is the 5-strings Music Man Stingray bass, and the one on the right is the 4-strings Peavey Dyna bass. This figure shows how the neck of a Stingray bass deforms due to vibration. The left side is the direction of the body. This measurement was performed using a laser beam. The actual amount of deformation is extremely small and cannot be seen with the naked eye. First, for number 1, the neck is deformed by the vibration of 42.3 Hz. 42.3 Hz is a frequency close to 41.2 Hz, the note of the open 4th string of the bass. Number 2 shows deformation at 137.5 Hz, showing a more complicated shape. This frequency is close to the 6th fret note of the 1st string. Number 3, the deformation becomes more complicated. This frequency is 282.8 Hz and corresponds to the note between the 18th and 19th frets of the 1st string. What about the number of peaks and valleys from number 1 to number 3? Number 1 has 1, number 2 has 2, and number 3 has 3. This corresponds well to the shape of the strings that produce the 1st, 2nd, and 3rd harmonics. This is a theoretically calculated deformation assuming the neck to be a simple cantilever. The left side of this cantilever corresponds to the body. Calculations assume that it does not move. This calculation reproduces the experimental result well. This result shows an important fact. That is, when the string vibration is transmitted to the neck, a certain frequency component of the string vibration causes the neck to resonate and some of the string vibration energy is lost. If the degree of this resonance is large, a certain fret corresponding to the resonance frequency will become a dead spot. The resonant frequency of a neck also depends on the type of wood used for the neck, and the mass and weight of the neck. The next thing we look at is conductance. Conductance is an index that expresses how easily sound is transmitted. This figure is the measurement result of Carvin bass. The vertical axis of the figure is the conductance, and the larger the value, the easier the sound is transmitted. The horizontal axis represents frequency. Many of the graphs are data for the nut, frets 2 to 12, and bridge in order from the back to the front. There is a large peak between 40 and 50 Hz, and the size of this peak is roughly constant regardless of the fret. There is also a peak between 125 and 150 Hz. In particular, the nut has the maximum conductance, and you can see that the sound is easily transmitted to the neck up to the 6th fret. This frequency range corresponds to the 4th to 8th frets of the 1st string, indicating that any of these frets can be a dead spot. Another important result is the extremely low conductance in the bridge. This indicates that very little string vibration is transmitted through the bridge to the body. This figure is the measurement result of Stingray bass, but it is almost the same as the previous result. However, the difference is that the position of the peak on the low frequency side has shifted slightly to the lower side, the conductance of the nut part is small, and there is a small peak near 275 Hz. Summarizing the above results again, string vibrations between 120 and 150 Hz correspond to the resonant frequency of the neck, so sounds at this frequency are attenuated. This figure shows how the entire guitar, including the body, deforms. You can see that the change in the neck is extremely large and the deformation of the body is relatively small. Such bending mode deformation is irrelevant to sound generation, and simply takes energy from the string vibration. His figure shows the relationship between the deformation of the entire guitar including the body and the frequency. From the left, it shows the state without deformation, first, second, third, and fourth mode deformations. As mentioned earlier, when the neck is regarded as a string, these deformation modes is the same as those of the string corresponding to the first to fourth harmonics. Summary of the content of this video. String vibration is transmitted from the nut and frets to the neck, but hardly transmitted from the bridge to the body. When the sound frequency of a certain fret is close to the natural frequency of the neck, the vibrational energy of the string is consumed by the mechanical vibration caused by the resonance of the neck and is greatly damped. This is the cause of dead spots. Since the natural frequency differs depending on the material, weight, and shape of the neck, the existence and position of dead spots also differ. The tone changes depending on the string vibration, including nth harmonics, absorbed by the neck and the magnitude of the absorption. Elimination of dead spots. If there is a dead spot on a fret, the frequency of the tone on the fret is close to the natural frequency of the neck. The natural frequency of the neck is determined by the hardness and mass of the neck material, but since the neck cannot be changed, it is necessary to change the mass or weight. Cheapest way to eliminate dead spots: wind 4 strings around the pegs without cutting the excess. As a result, the total mass and weight of the neck increases, the natural frequency of the neck drops, and the dead spots move slightly toward the nut, eliminating dead spots. Thank you for watching. If you are interested in stringed instruments, please subscribe to the channel and press the good button.